Hi guys, I decided to do a new little series on microcontrollers and specifically ESP32, mostly the S3 version, because they have an OTG capability, so they can actually host USB as well as act as a device. And I've got some projects in mind in the future, one of which is like I've got an old keyboard which I bought in 1990, which is a Northgate mechanical keyboard. It's the mother of all keyboards, and it has a socket on there from an original IBM PC, which was a large DIN plug. And it occurs to me that I can actually make perhaps a Bluetooth, turn it into a Bluetooth keyboard with one of these type of devices, where I pick up the keyboard input and then transmit it via Bluetooth as a HID device to Windows or whatever you are connecting it to, even a cell phone. So in order to do that, I need to know ESP32 and in fact the microcontroller stuff in more detail, and I have embarked on exploring that, and you can be there along with me. You will find some of the stuff will probably fail and so on, and we will have to bypass it. I already done some exploring, and I can tell you what I have done. So I actually saw this device online. They're not the cheapest device you can get. They're about 35 bucks, but when I saw it, I noticed that it had a USB device and a USB host socket on it, and I thought, oh good, I could probably use it as a dongle, plug it into a PC on that end and plug something else in it on the other end. And well, the long story is no, that won't work, because I haven't yet to find a board. There might be some of them around. I saw vague references to an Arduino Duo or something like that. But the truth of the matter is that if you want to use some of these devices as a host and a device on USB, you most likely need to get one of these kind of this is a USB shield. It's made for some Arduinos, but I think it can be used with ESP32. So we might even investigate that, like hook it up to one of these little guys here. Now these two over here are both S3 versions, ESP S3. This is a C3 version, so it has slightly different capabilities. But so we might investigate that. But in the meantime, I realized that we really don't need to use it as a dongle, in fact, because ESP32s, especially the S3 version, they have low power Bluetooth, BLE, and you could potentially plug like a device, a mouse, a keyboard, whatever device you want to plug into it, into the host port, and then actually transmit the information through Bluetooth as a HID device. So we'll be looking at all that stuff. Meanwhile, this one has a little display on it. I also have some larger displays that we will investigate as well. How hard is it to get that set up with on the Arduino side, and also there's LVGL, and I have a special device here which we'll be looking at in the future as well. It's in this little box here. It's one of these yellow things. It actually has an ESP32 processor on it, and it has a touchscreen attached. So, but that is coming up later. First, I want to familiarize myself with what libraries are out there, what code I would have to write, how I got them change it in order to make it work. So we'll be doing this in steps. This is there are going to be different episodes of this series of videos. I'll put them on a separate playlist. I'll call it ESP32 Adventures. And the first thing we're going to do is enabling this TFT display. Now, the one thing that I found out is that I just bought this thing a sight unseen because it said, you know, USB wireless disk. Development for that USB camera, USB dongle, Wi-Fi hotspot, virtual keyboard, etc., etc. So I thought this would be suitable. Well, it is. However, Espressif, they really cater more to the professional developers, I think, and electronics engineers, whatever, to do embedded systems. And in fact, this little device here, as you'll see later, has a little ESP mini that you can buy, ESP32-S3 Mini 1, that you can buy and actually place on your own PCBs and make controllers or whatever you are doing with it. And what I'm trying to get to is that they have their own development system called ESP-IDF. I had a brief look at it and I don't like it because it is specifically only targeting Espressif stuff, and I want to be able to have different microcontrollers. I have bunches of these things, including some older ones that I've bought years ago. Of course, I've got an STM32s. I have more of these different. This is a sort of a Chinese ESP32 vroom, whatever that means. I haven't really looked into that. I've had it for a while. Device, and so on. So I don't want to limit myself to Espressif's IDF system. And then really what we found out is that Espressif themselves, they don't officially really support Arduino. They do some of this stuff for it, but especially I want to use PlatformIO, and several people commented on some feedback that I've seen that they wanted to know something, and they asked Espressif if they're going to be supporting PlatformIO, and they said no, we don't support it. We got our own ESP IDF system. So when I got this thing, I found out that all the example code there is not really based as generic Arduino, although you can modify it. They have examples for the IDF infrastructure. So therefore, that is one of the reasons why we're going to be experimenting with this thing and seeing what we can make work just with the standard libraries and our own code. This thing here is a Seed Studio XIAO ESP32-S3. I really like these little guys because they are very small, and as I said, I might want to do a keyboard controller that will talk to a PC over Bluetooth, and this thing has a little stick-on antenna which you can stick inside the case. It's a little better than the built-in ones, so likely we will use one of those. Both of these, as you can see, I soldered some leads with little sockets on there. They can actually handle a battery. They have built-in circuitry to boost the battery voltage to 5 volts, and charging circuit as well. So when you plug it in to the various ports, it will actually charge the battery too if there is power on the USB ports. This thing here, I think it also might have that ability, but I'm not 100% sure. But we might try this as a generic ESP. This is a C3, which is a different controller, ESP32C3. But in any case, that's what we got and we'll be working with. So let's have a look at this thing, and why did I choose this thing to for this series as a base. Okay, so one of the reasons I'll be wanting to base my experimentations on this thing here is the fact that It has everything built in. I don't have to plug this in like if I was using one of these little guys here. I would have to plug it into a breadboard or something, or one of these things here. I'd have to plug it into a breadboard and add a display to it, switches, and also, of course, it wouldn't have the host port, so I'd have to use one of those little host controllers and everything. Well, this is all built into the one unit over here. I don't have to add anything to it, so that will be much easier to deal with. So what this actually has, as I said, it has a USB device port, which is a USB-A. They're actually all USB 2, in case you're wondering. They are not, none of these controllers handle USB 3 or upwards, but that is fine for our usage because, keyboards and mice and everything, they don't need more than 12 megabits per second or whatever they can transfer. It has the USB host port on there, and you can switch from one to the other. And the circuitry for doing that is on board, and we will look at that in a second. It has a battery connection that I've soldered on, pads for that. It has a switch to turn the battery on, power from the battery on or off. Don't even have to add that. It has a bunch of buttons. You can kind of see a little button over there, and there's one over there, and there's another one underneath that ribbon cable for the screen there. Yeah, of course it has a screen built in, 240 by 240 pixels. It has a third USB port, which is actually a USB UART, because this one goes through a chip to turn the USB signals into serial input to the chip, and of course you can download code and look at the serial monitor through that. But on this device, because ESP32-S3, they have their own USB thing as well built in, so you can actually use this port as well if you want to. But of course, if you're using the host port, then this one would be disabled, so that's why the third port there, you normally use that for programming and what have you. There is another button on the top there. They put menu on it. Now these names of these buttons are actually insignificant. They're just standard buttons hooked up to the GPIO pins on the controller. It has an SD card reader built in, and you can see it is sticking out over there. I plugged something in there. We'll be looking at that as well to enable that. And that's the restart button over there. So underneath, you will see they've done a really nice job to show us all the different components. As I said before, this actually has a little board on there, which is called an ESP32-S3 Mini, which is connected to this bottom board on the other side. There is actually two boards. There's a top board and a bottom board, and they are held together with these little screws and nuts here. This thing then provides the ESP32-S3. It's the heart of the system. It's got the RAM and the ROM and the flash and what have you on it, and stuff that is common. And of course that is the antenna over here for the Wi-Fi and the Bluetooth. All that is fine. Doesn't have an external antenna connector, but for our testing here, this is sufficient. So then from left to right here, this is the USB micro USB port, and that's connected to this chip over here. That is the chip that does the translation from USB to serial. Then the LCD has a backlight. There's a MOSFET here to switch that on and off, and the LCD also has data pins and stuff. It goes through that like a kind of like a ribbon cable thing or whatever you call that underneath there, and there is 1, 2, 3, 4, 5, 6 components on there. Some of the, I think they're mostly resistors, We will see those on the circuit as well. Then there is the device control. These three MOSFETs over here control the power. It can take power in from this USB-A port and direct it. If you enable the USB host port, then it directs the power from there to the host port. So whatever you plug in there will be powered by either the input from here or from the battery. So these are involved in doing that. They can switch the power from the battery or from the USB dev port input. Then if you use host mode, you have the option to limit the output to 500 milliamps, and if it tries to draw more power, then it will do something about that, and it will send a message to, I think it's GPIO 22 or something, if I remember correctly. We'll see that in a minute. There'll be a pin there that goes high, so you can actually, in your software, you can actually scan whether a device has been plugged in that is doing something nasty to the power, and take action, bring out error messages and switch things on and off and all that kind of stuff, I guess. Now, if you are running, if you've got the battery switch here turned to the battery mode, then it needs 5 volts, so there is a boost circuit here, the usual sort of thing with a little inductor and some capacitors, and this is the boost controller on there. The battery connections are now soldered that up, and I put some hot glue on there to stop the wires from bending so that they fall off. There's 2 little pads under there. Then this circuitry here, which is partially hidden, I guess, by the wires and the glue, but there's a little controller there that's for the charging, and there's an LED underneath there that actually will light up while it's charging and goes off when it's full, I believe. Now, if you are running it off 5 volts, either through this USB dev port or through the USB micro port here, then the actual ESP32 controller and a lot of the circuitry needs 3.3 volts. So there's a buck regulator over here, also a little switch mode regulator with an inductor and the usual, as I said, some capacitors and things, feedback and smoothing out. That provides 3.3 volts. And then there are some spare pads over here that you can solder wires to if you actually need them. A couple of ground pads. Here is some additional GPIO pins, 45, 46, 26, 48, 3, and 47. I'm not expecting to need those during our experimentation. There's 4 pads here, which are actually JTAG pads that can actually you can do things with if you got a JTAG controller or something. There is like an ESP prog thing or something. You can actually download programs to it, and also you can use it for single stepping and debugging and stuff like that, which potentially you could hook up to those 4 pads. However, the ESP S3 has its own built-in debugging circuitry, so I'm not expecting to need that either, which comes out of the this port here, the USB dev port. Okay, so we can demonstrate that. If you watch the ports and common LPT ports here on the device manager, I'm now going to be plugging in the USB micro port, which you would use for uploading code and stuff like that, and can be used for the serial monitor. And you'll see COM port 17 on my computer, at least, Silicon Labs CP210X USB to UART bridge. So that's the one marked USB-UART 0 on the case here. Now I will plug in the USB-A port, the male one, into the computer, and this is marked as USB dev. And now you will see that we got USB JTAG serial debug unit interface 0 on COM 7. So these are the 2 different ports that it has, and they can be used for different purposes. I believe that this one here can be used for debugging, like single stepping through your code and so on. And I don't think the other one does. It just turns it into serial data. So now let's have a look at the documentation and the circuits to see how that all comes together. Okay, so this is the documentation that you'll find on Espressif's website. If you search for ESP32-S3-USB-OTG, you will find it. And we've already discussed some of that stuff. It has an onboard ESP32-S3 Mini, which we can have a look at. This is the actual data sheet for it, also on the Espressif website. This is the one that we have with the little antenna on it, this one over here. And that gives you a bit of information on it. 384 kilobytes of ROM, 512 kilobytes SRAM, 16 kilobytes in RTC. Not sure what it is. RTC is a real-time clock. I know it has that. Up to 8 megabytes quad SPI flash. And in fact, that's what we have. We've got 8 megabytes. And usual things, Wi-Fi, some information that Bluetooth 5, and so on. Not much really else to say about it as a standard sort of ESP32-S3 module. Okay, so back to the ESP-S3-USB-OTG. That's what it looks like. Already looked at it. Now over here you see an image of the actual board that we can't see because the LCD board on the top of it is mounted on top of it. Again, that's the ESP mini module there, the USB to UART interface, the micro USB port, some buttons, the screen connector, the boot button, the power switch, the SD card slot, and this is actually the chip that actually switches the data signals either to the dev interface or to the host interface. That's why you can only have one active at a time. There is not a separate sort of a host interface, as I said. And of course that chip controls as you'll see on the circuit, as I said, the data D plus, D minus. Information that we have probably already discussed. Here's some we've looked at the back of it already. Oh, it's also got a couple of LEDs on there, a yellow and a green one. That you can access. As I said, everything is on the board there. We don't have to connect wires to it. We don't have to plug it into a motherboard, into a breadboard, sorry, so that makes it all a lot simpler. Okay, so here is a block diagram of the thing. So you can power it to the micro USB, or you can power it to the USB dev interface, power supply to the battery, set boost EN to a high level, and there's a little, see that's the pads that we soldered the battery to. Now I've got a much larger battery than that one, but it works the same. And you'll see this is the boost circuit that we looked at, and of course that is over here. This is the boost circuit here, and that's the inductor is partially hidden by the wire over here. That's that this is it over here, inductor, capacitor, few resistors. There's a capacitor there, and I think there's another one hidden somewhere. Anyway, that's what that is. That's a boost circuit. And now this is kind of important. As you are developing your software, it depends on where you want the power to come from. If you're using the host interface, so the USB host interface power supply selection, yeah, there's two signals there on GPIO pins, and later on the table you see which pins they are. If you set boost enable to low and dev VBus enable to high, then the power is, and that's the default, the power comes from the USB dev USB A plug. But if you set boost enable to 1 and dev VBus enable to low, to 0, then it comes from the battery. And the other two conditions are really not used. So we will be playing with that in our code later on when we use the host port. So these are the three MOSFETs, and that is the guys over here. 1, 2, 3, VBus dev control, which we looked at earlier. They will either send the power, from the dev bus to the host, or it'll come from the battery. So that's what that is all about. There's the 500 milliamp limiting circuit, which is over here. That's it there. There is the USB interface circuit switch. Now that's that little chip that is not visible on this side of the board, that's on the other side. As you can see, it switches the D plus and the D minus USB 2 signals from either to the dev port or the host port. And that is controlled by the input from the there's a GPIO pin, GPIO, I think it is 18, yeah. So when USB cell GPIO 18 is set to high level, the D plus and D minus pins, which actually come from GPIO 19 and 20, because the ESP32 has its own built-in USB circuitry, so they always have a couple of pins assigned for that. They will be connected to the dev, otherwise it will be connected to the host. LCD interface. There's a bunch of resistors here, which I think probably is what these things are here. And that's just the control pins. They have GPIO 4, 5, 6, 7, and 8 involved with those. And that is what we will be looking at when we run the TFT library, that we have to define where the code is going to find its signals for that, its SPI interface. It uses an ST7789 controller. There's a data sheet for it, but we don't need to look at that because the library will take care of that. SD card interface, that is a bunch of diodes. Actually, they are special diodes. They are bidirectional Zeners, and they actually make sure that the voltages applied will never exceed a certain voltage. There's a protection. And then there's a charging circuit. There's a switch there, which is actually, you can barely see it over here. There's a little thing sticking out. Switch sits right underneath here, and it has a little charging circuit over here, and a little LED shows it when it's charging. And that's basically it. Then there's the pin layouts here. which we will be looking at in due course when we use them. It says VBus and Boost Enable C, GPLE 12 and 13 that we discussed earlier, some free pins, and that's basically it as far as documentation is concerned. Now in this series we are actually going to be using PlatformIO. We are not going to be using the Arduino IDE. The reason being is that PlatformIO is way faster and in fact more convenient in a lot of ways. It is more aimed at more professional developers or makers or whatever you want to call people that use microcontrollers. And the Arduino IDE 2 is very slow. I mean, I've got a PC here which is basically up to the standard of being a high-level gaming machine, and yet it's just slow. I don't know what they're writing their IDE in, but it's obviously not a low-level language. In any case, also the PlatformIO, because it is based on Visual Studio Code, is got a more powerful editor. It's got better IntelliSense and lots of other stuff that I like as a professional, ex-professional, retired software engineer. That is what I use. It also you can use it with Git if you want to use put your code on GitHub or something like that. In any case, if you haven't got it installed already, then as you can see, you can go to https visualstudio.com download, and you'll find the Windows version there and Linux and even for a Mac. Now I do not support Apple platforms at all. I have a personal aversion to Apple. Goes back to 1983. It's a long story which I'm not going to go into right now, but I don't like Apple as a company, never have and never will, so I refuse to use their stuff. Cell phones, computers, forget it. Anyway, so that's one thing. Linux I do have on my machine, but I find that using Windows is just easier. Everything just kind of works. And Linux, quite often you will have to put in some extra drivers and this, that, and the other. You've got to have a bit of knowledge about your operating system, and it's just easier right now to use Windows, so that's what we're going to be using. So in any case, here you can download it, and you can use the x84 version, and once you've done that, you can actually go into Visual Studio Code, and you can actually go and if you want to know, you can actually Google it, and it'll actually how do I install PlatformIO. There's even a video on it there on how to do it. You download Visual Studio Code, open VS Code Package Manager, search for the PlatformIO IDE extension, and install it. And PlatformIO itself has documentation. It's on https docs.platformio.org and so on. And it has installation instructions as well, and of course everything else too, mostly. In any case, this is what we're going to be using, so if you don't have it already installed already, then feel free to do that. Okay, so that's all we have for this episode, just to get started. Next episode, episode 2, is going to be on TFT Displays and how to get those working with Arduino and PlatformIO and so on, and the libraries for them, how that works and how we can get set up with that and all that sort of stuff. And that includes a 3.2 inch display I've got here, and also the little display inside of the ESP32-S3-USB-OTG board. So what we have is we're going to be looking at this LC Wiki here. They have information here about every LCD board that you can think of. and OLED displays. This is a first stop that you can go to in order to have a look how to find out the parameters on your boards. And for instance, this is the board that we have to play with. It's got touch on it as well, which is an optional, so it gives you all the parameters here, and in fact you can even download documents about it and software as well. So that's what we're going to be looking at on the next episode. And don't forget to subscribe and to like, and also to hit the little bell button or whatever that is called, so that you will get notified when the new episodes are going to be posted. I will have created a playlist called ESP32 Adventures, so they should all be under that. A bit easier to find that way. And that's all I've got then, and I'll see you guys later.